Welcome back. I'm looking now at the Android Studio IDE as it stands after creating our application. Android Studio opened up two files for us, one called activitymain.xml and one called mainActivity.java. So we have a Java class that is our activity, and we have an XML file representing the layout. Right now the XML file is in the forefront, except that what we're seeing is not XML. What we're seeing is a series of previews in terms of a palette of widgets, a component tree, properties of the various widgets, and a view of the device if this application was currently deployed. Now at the bottom here, you'll see that I have a design tab and I have a text tab. If I go to the text tab, now I can see the actual XML representing this application. So that we see that we have a relative layout, we have a series of attributes involving padding and everything, and then I have something called a text view. Again, I mentioned one of the challenges with dealing with Android is that the terms they use don't necessarily correspond to the terms we're familiar with. If this was Java Swing, if you were writing a desktop Java application back in the late 90s or possibly somewhat since then this would be called a label, or rather a JLabel. This would be an instance of an unmodifiable string, JLabel. If you were writing HTML, this would be a label. But in Android, this is called a text view. The text view has an attribute called text with Android prefixed in front of it, and a layout width and a layout height. Every widget inside of Android has to have a layout width and a layout height, and our two primary options for the width and the height are wrap content and match parent. Wrap content will make this widget just big enough to hold whatever contents we specify for it, whereas match parent will make the width or the height or both exactly as big as the parent that is holding it. In this case, the parent would be the relative layout itself, which, by the way, also has a layout width of match parent and a layout height of match parent. We also have a set of padding options, left, right, top, and bottom. The Java class, however, extends the wrong class, in my opinion. We are extending something called AppCompat_Activity, which is part of a compatibility library. It's a rather odd quirk of Android Studio at the moment that even though you say that you don't want to work with older devices, it still extends AppCompat_Activity rather than activity itself. You can see if I open up the imports that there's an import for the support version 7 library .app.appCompat_Activity, as well as several other classes that are needed within this class. So my public class main activity currently extends AppCompat_Activity. What I wanted to extend is just activity, but one of the nice things about Android Studio now is that it will adjust this for me automatically. So watch this. I'm going to delete AppCompat, and when I pause, then it automatically switched the import from the AppCompat_Activity to Android.app.activity on my behalf. You saw there was a brief moment where things were not found, and then it was all fixed and up to date. Very useful characteristic of the IDE. Another interesting characteristic of the IDE, especially for people who are accustomed to a more Eclipse-based environment, is that I didn't have to hit save. In IntelliJ IDEA, and therefore in Android Studio, you don't have to explicitly save anything. The editor windows will be saved automatically whenever you pause for more than a few milliseconds. So that not only saved, it also compiled, and now everything is okay. Inside here, we see a whole series of callback methods. On create options menu, on options item selected, and those are the ones that were built in to the basic activity. We're going to go through these in some detail a little bit later, and we're going to see that Android applications are enormously composed of callback methods. This is not terribly much of a surprise. Most IDEs respond to callbacks, button clicks or text widgets or whatever you might have. And in this case, we have additional lifecycle activities associated with things like hitting the back button or rotating the device or things of that nature. Now, right now, I want to actually take a moment and look at the SDK Manager to see what I currently have installed. Now, there are multiple ways to do this, but there are some buttons near the top. This is one way, and I've moused over one whose name is the SDK Manager. There's also the AVD Manager, Android Virtual Device, which is going to be our key to starting emulators. There is a synchronized project with Gradle file widget, and there is an Android device monitor. Let me start with the SDK Manager. Now, I clicked on that, and one of the things you'll see that is a little bit different from what you may find when you download the SDK is that I'm not actually using the SDK that was included with the IDE when I first downloaded it. I'm on a Mac. I installed my Android SDK using a mechanism called Homebrew, which is a package manager or an application manager for Macs. The only point I'm trying to make is you can install your SDK separately from the IDE and manage it that way, and then Android Studio can be configured to work with what you already have. My point is that my SDK is at a particular location, user local seller Android SDK 24.2, and it now shows me that within that, here are the various versions of Android that I have currently installed. Again, you will, in your own situation, you'll probably have a very small subset of this. I have this tendency to install everything and try to update them whenever available. That's a bit excessive, and on some of the older ones, I've decided not to update all the time anymore. There is a link here to launch the standalone SDK Manager, and that's something I use on a regular basis. So I just clicked on that link, and here is what the resulting SDK Manager looks like. Notice everything is downloaded, and then they check things where updates are available. And you see here that we have Android SDK tools and something called platform tools. The distinction is not all that important for us. What you need to know is you need both. You need the SDK tools and at least one version of the platform tools as well, and then one version of the build tools. I have several installed, mostly because I had older ones installed and I just keep updating, and that adds new ones. I could uninstall some of the older ones, but I just haven't bothered. Then we get each individual version. Here's my Android M preview, API 22. And we have documentation and the SDK platform and samples and various emulator images. There's 5.1.1 with, again, documentation, SDK, samples, and various things to support the emulators. And then 5.0 and so on and so on. The 4.4W is Android Wear. That's what the W stands for, is Wear. 4.4.2 is API 19, and then 18, 17, on and on and on, all the way down to this section here called Extras, where you can find all the Google support libraries, the Android support libraries, the Google AdMob section, the analytics, cloud messaging, the Google Play services for the various types, the repositories, billing, APK, etc., 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 all the way down to the bottom. That's the Android SDK Manager. You can select pieces, you can click install, you can remove things, you can do whatever you like. And once you've completed that, then you can start using any or all of these within your Android Studio IDE. In the next section, we'll go back to the code there and start making modifications to it so that I can run this application on an emulator.